Today our lesson is on systems of equations. This time we will be doing the first elimination lesson. As usual, there is a video guide to go along with this video, so if you haven't printed it yet, go ahead and pause the video, print the video guide, and then come back and work out these problems with me. So, taking a look at these problems, we're going to work these out a little bit differently from the substitution problems that we worked out before. The reason why is because you'll notice both of these equations are in standard form. Neither one is solved for y. So standard form equations, to get it to be solved for y, we'd have to first solve it, and then we would have to use substitution and solve the equation again, and then we'd have to take that answer and plug it in and solve again. So it's a lot of solving involved. All right, so there's actually another method that we can use with a little less work to it. So looking at this one, the word elimination means we are going to eliminate or get rid of one of the letters, okay? Elimination means to get rid of or to cancel out so that it's no longer in the problem. So looking at this, we're going to kind of work this problem like a big addition problem is how we're going to start it. So we're going to look at the two equations and compare the letters. I have a negative 4x in the first and a positive 4x in the second. You'll notice that these are the same letter, same number, but opposite signs. This one's negative, this one's positive. So if I would add these two together, I would get 0x, or just 0, okay? There wouldn't be an x anymore. They would cancel out, which is exactly what I want. That's what elimination means. Taking a quick look at the y's just so that we can identify the difference here. This is a negative 5y, a positive 10y. If I were to add these together, negative 5 plus positive 10 is positive 5. They don't cancel out. So you'll notice for the x's, same letter, same number, opposite signs. That's what you need for elimination to work. And that's what we have here for the x's. And that's all we need. We only need one letter to cancel out. We don't want both of them to cancel, just one of them. So we're going to make this one big addition problem and add the two equations together. Okay, so adding like terms. Negative 4x and positive 4x. We already said that 0, those cancel. So I'm not even going to put the x down here anymore because it's gone. It's been eliminated. But I am going to do the y's. Negative 5y and positive 10y. We said that when we put those together, we get positive 5. So I have positive 5y here equals negative 16 plus 16. Same numbers, opposite signs, that's going to be 0. And I put the 0 this time because you always have to have something on each side of the equal sign. So I've got to put 0 because there has to be something over here. And then I just solve this equation for y. This is 5 times y equals 0. So to solve for y, I just divide by 5. And I get y equals 0. Now, just like the substitution problems, this is only half of our answer. I also need an x-coordinate, okay? So, we used elimination for this first part, but we are going to go back to a little bit of substitution for the second part. What I'm going to do is look at these two equations, and I'm going to pick the one that has the smaller numbers. I'm going to go with the first one. 4, 5, and 16 looks a little easier to me than 4, 10, and 16. So I'm going to go with the first one. I'm going to substitute, but I'm going to substitute in for y. If y is what we know, y is what we substitute for. That means the negative 4x will stay the same. My minus 5 will stay the same. But instead of y, I will substitute in 0 in parentheses. And that equals negative 16. Okay, so we're going to use substitution this time. Now, you're not always going to be substituting in for x in that last step, which is what we're used to. So please, please, please pay attention to what you solve for in that first part, because that tells you exactly where to put that number, okay? If you solve for y, put 0 in for y. If you had solved for x, you would put the number in for x. Whatever you solve for, that's where it tells you exactly where to go, in for y. So now I just solve this for x. I need to do my multiplication first, so I have negative 4x. Negative 5 times 0 is just 0, equals negative 16. All right, well, negative 4x plus 0 is just negative 4x. Adding 0 to anything doesn't change it, so it just pretty much goes away, okay? And then to solve for x, I need to divide. So I divide both sides by negative 4. The negative 4's cancel. I get x equals positive 4. So I have my y, I have my x. I need to write my point. Remember, when you write your point, x always comes first. Okay, it doesn't matter which number you found first, x always comes first. Alphabetical order, x, then y. So x is 4, it comes first. Y is 0, so it will come second. So my answer is 4, 0. And that's our solution for number 1. For problem number 2, our equations are negative 5x minus 7y equals 6 and 4x plus 7y equals negative 16. First thing you need to do is check and see if anything can be eliminated right away. So looking at our x's, I have a negative 5 and a positive 4. The letters are the same, the signs are the opposite, but the numbers are different. They won't cancel when I add them together. I'll get negative 1. So that doesn't help me. So now we take a look at the y's. They're the same letter, same number, both 7s, opposite signs, minus, plus. Those will cancel if I add them. So I can go ahead and add these two equations together. Negative 7, positive 7, those are going to cancel out. I'm going to add my x's together. Negative 5 plus 4, the signs are different, so I subtract them, keep the sign of the bigger number, negative 1x, equals 6 plus negative 16. The signs are different, so again I subtract. 16 minus 6 is 10. Keep the sign of the bigger number, negative 10. So to solve for x, at this point I just need to divide. Divide both sides by negative 1 to get x by itself. I get x equals negative 10 divided by negative 1 is a positive 10. Remember, if the signs are the same, it's positive, always. So this is our x, but now I need to find y. So to find y, I go back. I could do 5, 7, and 6, or I could use the numbers 4, 7, and 16. I don't really want to use 16 if I don't have to. Again, I'm just staying away from the bigger numbers, so I'm going to go ahead and use this first equation. X is what I solved for this time. So that 10 will go in for x, all right? Always look and see what you solve for. I solve for x, the number goes in for x. The first problem we solved for y, so we put the number in for y. Gotta pay attention to what you solved for that first time. So put the 10 in for x. My negative 5 stays the same, but instead of x I put 10. Everything else stays the same. So minus 7y equals 6. And then I'm going to go ahead and solve this. Do the multiplication first. 5 times 10 is negative 50 minus 7y equals 6. So to solve this for y, I need to cancel out the negative 50. So the opposite would be positive 50 plus 50 here plus 50 over here. Both sides. They cancel. My negative 7y stays the same. 6 plus 50 is 56. And my last step is to divide by negative 7 on both sides. So I get y equals 56 divided by negative 7 is negative 8. So my solution, always put the x coordinate first. Always, always, always. So my x coordinate is a positive 10, comma, my y coordinate is a negative 8. Negative 8. So 10, negative 8 is the solution for problem number 2. For problem number 3, our equations are negative x minus 4y equals 25 and 5x plus 4y equals negative 13. Just like before, check and see if anything can be eliminated right away. So negative x and 5x. Same letter, different signs, but the numbers are different as well. Remember, this is a negative 1x. They don't put the number there, but that's what it means. So these are not going to cancel. Let's look at the y's. I have a negative 4y and a positive 4y. Letters are the same, numbers are the same, signs are different. That's perfect, exactly what we need. So I can add these two equations together the way they are. Negative 1x and positive 5x, the signs are different, so I subtract, keep the sign of the bigger number. So 4x equals 25 and negative 13. Same thing, signs are different, so you subtract, keep the sign of the bigger number. So it's going to be positive 12. So now to solve for x, I just need to divide. Divide both sides by 4. 12 divided by 4 gives us 3. So x equals 3. That's part of our answer. Now we need the other part. So to find the other part, we use 3 for x, and I plug that into one of these equations. I can either use the 1, 4, and 25, or I can use the 5, 4, and the 13. I'm going to go ahead and use 5, 4, and 13. Again, the 13 is smaller than the 25 by like 12, so I'm going to go ahead and use that one. This is solved for x. It says x equals 3, so put the 3 in for x. It tells you exactly where to put it. If it's solved for x, put the 3 in for x. If it's solved for y, put it in for y. So the 3 goes in for x. So I'm going to have my 5, but instead of x, I'm going to put 3 plus 4y equals negative 13. Everything else stayed the same. The only thing I changed was the x. Everything else is the same. So my first step is to do this multiplication, get rid of those parentheses. So 5 times 3 is 15 plus 4y equals negative 13. Now I need to get my numbers together. Got to cancel out that 15, so I'm going to do negative 15 or subtract 15. 15 and negative 15 cancel. 4y comes down equals negative 13, negative 15. The signs are the same, so I will add them. Keep the sign of the bigger number. So it's negative 28. And then my last step is to divide. I'm going to divide both sides by 4. So we get y equals negative 7. Now for my answer, always put the x coordinate first. X and then y, alphabetical. So my x coordinate is 3. My y coordinate is negative 7. So 3, negative 7 is my solution for number 3. At this time, go ahead and pause the video, work on problem number 4, get your solution, and then come back and check your answer with my work. For problem number 4, our equations are x minus 2y equals 15 and negative x minus 7y equals 12. You'll notice that right away I filled in those ones. I wanted to make sure that I knew what number was in front of those x's. So I go ahead and put the ones in there. Remember, anytime you have a letter without a number in front, you can always put a 1, okay? So that shows me this is a positive 1x, negative 1x. Those are eliminated when I add the two equations. Negative 2y and negative 7y, I got negative 9y, and 15 plus 12 is 27. So from there, I just divided both sides by negative 9, and I got y equals negative 3. Now, from there, you'll notice I have two sets of information here. You could have chosen either one of these equations, and I just want to point out that you would still get the same answer. So it didn't matter which one you chose, you still should have gotten that x equals 9. So if you pick the first one, you would put in negative 3 for y, do the multiplication, x plus 6 equals 15. You would then subtract 6 from both sides, and you'd get x equals positive 9. If you chose the second equation, putting in negative 3 for y, multiply this out, negative 7 times negative 3 is positive 21. You would then have to subtract 21 from both sides. You'd get negative 1x equals negative 9, and then divide both sides by negative 1. You still get x equals positive 9, so it does not matter which one you choose. So don't spend a long time trying to figure out, okay, which one's smaller, which one do I have to use? If neither one really jumps out at you, just pick one and go with it. They're both going to give you the exact same answer. I got x equals 9 for both of them. So it should not matter which one you choose. Just be careful on your steps and your signs, and you should be fine. So my answer, I put x first, x is 9, and then y is negative 3. So 9, negative 3 is our solution for problem number 4. And that's the end of our lesson on systems of equations using elimination, lesson number 1.